Alright. وبزعم بولي سيبون أو بولي كأبت وبزعم مجموعة شوار تلبيتها بود من كردي نازنن بويا إن شاء الله بإنجليزي شرح ينوار. Alright, yesterday we talked about solutions. We talked about types of solutions according to their physical states. We said if the physical states of the solutes and the solvents are different at room temperature, and we have different types of solutions, for example gas in gas and so on, according to the table that we studied here. And we had some other notes about solutions. We talked about alloys, and that alloys are mixtures of two metals. When two metals are mixed together, they become alloys and they are solutions. What else did we talk about? And we talked about gold, how 24 karat of gold is 100% gold, while less than that it's all becomes solutions. From 22 karat or 21 karat or 14 karat, they are all solutions of gold, which they are mixed with silver. Now, so that was solutions, the first type of mixture. Let's get to the second type of mixture, which is suspension. Suspension is exactly opposite of solution. What I mean by exactly opposite, solutions particles were small. Solution particles couldn't be filtrated. But if you look at suspension is a mixture when the particles in a solvent are so large that they settle out. It means that they precipitate in the bottom unless the mixture is constantly stirred or agitated. So if we this is called written before settling. Before settling means it's constantly stirred or agitated. Agitated means shaken or moved around. So if they are constantly moved around or agitated, they will still be like this. But if we leave it for a while without agitating, without stirring, we get this one, which the particles are precipitated. If you see that, the big particles are in the bottom of this container, and the smaller, very smaller particles are here. But the big particles have been separated. When you see this separation, when you see this precipitation, or we call it settling out, this is a suspension. We call it a suspension. Example, muddy water is a suspension. So anything that you can see that has a large particle and it's precipitated in the bottom, it's called suspension. Let's look at the properties of suspensions. The particles have a diameter of 1000 nanometer, but the particles of solution were between 0.01 to 1 nanometer. So they were actually smaller than 1 nanometer, while particles of suspension are bigger than 1000 nanometer. So they are actually very large. Since the particles are very large, and you can see there is no uniform composition in these mixtures. They are not uniform. If they are not uniform, then they are heterogeneous. Mixture. Of course, as we said before, they settle out when left standing. Left standing means when you leave it without any movement, then they will precipitate. For example, sometimes you leave a juice, not every type of juice, but some types of juice, which we have it here, which is a powder juice. For example, there are some particles that they don't dissolve, or there are other stuff also that they don't dissolve in water. When you leave it, for example, for a day or two, and you come back to it, to the container, you can see there are some particles left in the bottom. It means that those particles don't dissolve if they don't dissolve, because sometimes we just don't dissolve by ourselves. We leave it, they can be dissolved. But if they cannot dissolve at all, even if we stir it, if they cannot dissolve, then that mixture becomes a suspension. And as I said, I will talk about scattering light in the end of these mixtures, but suspensions may scatter light, but they are not transparent. We'll come back to that later on. So that was all about suspension. We didn't have a lot of things about suspension, only those properties. In which of the following, in this question, in which of the followings the particles have a diameter size bigger than 1000 nanometer? See? Sugar water. Sugar water is a solution. It's dissolved. Muddy water, yes. Muddy water is a have big particles. An alloy of silver, this is also a solution. Milk is the third type, which is colloid. That's why milk is not a suspension. All right? It's not a suspension. Now here's the third type of mixture. Colloids. Colloids بكردي هم هرچانه كلمه چی بابلن باونيا بس بكردي بيوتري ملاكاني بيوتري. Colloids are actually an intermediate between solutions and suspension. As you can see, particles that are intermediate in size between those in solutions and suspension form mixtures known as colloidal dispersions or simply colloids. Colloidal dispersions or simply colloids. So colloids, even with properties, they are in the middle. They have some properties of solution. They also have some properties of suspensions. Let's look at the properties. For solutions, you remember solution, they were between 0.01 to 1 nanometer, while suspension were bigger than 1000 nanometers. 1000 nanometers. What about in between? The in between is for colloids, which is 1 to 1000 nanometers. And they are heterogeneous mixtures. Of course, they are heterogeneous. So this property is kind of like the suspension, but they don't settle out. They don't precipitate. So they are heterogeneous, yes. Their compositions are not uniform, but they don't settle out, just like solutions. That's why we say that colloids have a property, or it's like in the middle of suspension and solution. And they scatter light and are transparent. What does scattering light mean? The colloidal particles make up a dispersed phase and medium is dispersing medium. So this is actually not related to scattering light. This part is not related to scattering light. Colloidal particles, if you remember from solutions particles were dissolved. But for colloidal particles, we cannot say they are dissolved. What do we say? They are in dispersed phase. The medium is called dispersing medium. Let me clarify more about colloid. What is a colloid? Like, what kind of think of colloid? Which things are colloids? So, smoke, for example, is a colloid. Smoke is a colloid. Let me give you an example how smoke, or let me clarify how smoke is a colloid. Smoke particles. If smoke is spread out through air, smoke is in air. What is smoke? Solid particles in air. They are very small, solid particles in air. But they don't precipitate. See? They don't precipitate. Alright, they don't precipitate. But are they distributed equally throughout air? Do they have a uniform composition? No. Because if we take samples, for example, imagine the room that you are sitting in. Smoke is spread out this room. And we take samples in different places in that room. we can conclude that the samples are actually different. None of them resembles the other one. Some of them contains less particles, some of them contain more particles. That's why they are heterogeneous. So smoke is a colloid. What is a colloid? Steam or fog, mist, fog is also a colloid. For example, in a foggy night or foggy day, you go out, the particles are distributed throughout the air but not equally. They are, what do we call it, dispersed. They are dispersed throughout air, dispersed. Then what is air? Air is the dispersing medium. So the medium, the bigger thing, is called dispersing medium. We don't call it solvent because they don't dissolve. If you remember in solutions, we said solute and solvent. But what about colloids? Dispersed particles, not dissolved, dispersed particles, and the medium, instead of saying solvent, it's called dispersing medium. All right, dispersing medium. What else is a colloid? Solid particles, some solid particles disperse in liquid, such as paint. For example, paint is also a colloid. Gas disperse in liquid, foam, and whipped cream. So the foam that we have in a soap or in our shaving cream or whipped cream that we eat, all of those, there are small bubbles of gas trapped inside the liquid. They don't precipitate, but they are distributed among the mixture, but they don't have a uniform composition. That's why instead of saying dissolved in a liquid, what do we say? Dispersed. Agar agatan lebe lebri blend tuwa watawa, alen dispersed bo below to part bo lanavia. Another example. This example is very important. Emulsion. Emulsion is also a colloid. Then what is emulsion? When two immiscible, what does immiscible mean? They cannot be mixed. You can write immiscible. It means that two liquids which cannot be mixed or can't dissolve in each other. That's what it means, immiscible. So when two immiscible liquids, two liquids together, are dispersed, see, dispersed, not dissolved, in each other by help of an emulsifying agent, they are called emulsion. Let me explain these two sentences. For example, you have two liquids. They cannot get mixed. They don't dissolve in each other. Then, by the help of something else, we can mix them together, but they don't dissolve in each other. We can mix them and make a new substance, for example, a mixture. Like what? Like oil and water. Oil and water normally don't dissolve in each other. They don't get mixed. But we can make oil droplets to be dispersed in water. So what is oil droplets? They are dispersed. The dispersed particles. What is the water? Dispersing medium. Alright. But normally, as we said, normally these two cannot get mixed. Then what do we have to use? An emulsifying agent. What is the emulsifying agent? Egg yolk. Egg yolk can be used to mix oil and water. How? This egg yolk somehow grabs the oil and grabs the water together and keep them inside each other. The oil droplets will stay dispersed inside the water. This example, please write this down. This emulsion that we have oil and water are actually used in mayonnaise. They are used in mayonnaise. So in mayonnaise, the thing that we eat, the normal mayonnaise that we put it on our sandwiches, are actually oil and water. Some of them are oil and water. Yeah, they have other things too, other flavors too. But the basic thing is oil dispersed in water, not dissolved. Dispersed in water by using what? By using egg yolk. By using egg yolk. So that is also a colloid. I hope you don't have any questions. You all have understood. So these are examples of colloids. All right. Let's continue. There is a table. This table here. In the next page. This table, until now, until this year, we haven't seen like a lot of questions coming, or no questions actually asked in this table. But we assume with the other teachers that there in these couple of years there might be some questions asked in this table. For example, if we look at the phases, these are also all colloids, examples of colloids. Solid dispersed in liquid. See, all of them are called dispersed. Like what? Paint and mud. Second, solid network extending throughout liquids. So this is also solid, but they form a network. They are bonded to each other. These solid networks, they form bonds together throughout the liquid like gelatin. This one, liquid dispersed in a liquid. Liquid dispersed in a liquid like milk and mayonnaise that we said before. This is also emulsion. You can write emulsion here. What else do we have? Gas dispersed in liquid. Shaving cream and whipped cream. Solid dispersed in gas. Solid dispersed in gas. Like smoke. See, the smokes that we talked about before. Airborne particulate matter. Airborne particulate matter, any particles, any solid particle that's in the air. Airborne means in the air. Auto exhaust, again, is the smoke that comes from out of the exhaust of a car. Liquid dispersed in gas. Liquid dispersed in gas. If we look at this point, in the previous lesson, we talked about gas dissolved in liquid, like CO2 in water. But here, liquids can never dissolve in gas. قد liquid لأنه غازات وتو أي شيء ليه بس only dispersed. Only dispersed. Like what? Like fog, mist, clouds, aerosol spray. So they are liquid dispersed in gas. That's why these are colloids. They never become solutions. Liquid in gas never becomes solution. Liquid dispersed in solid. Liquid dispersed in solid, like cheese and butter. So it's better to memorize this table as well. It kind of you have to recognize it. I think it's easy to memorize it because since your questions are multiple choice questions, so try to recognize it in a way that you can answer the questions. You don't have to memorize it like a poem. All right. So those were the examples of colloid. As we said, colloids have an intermediate property between solutions and suspensions. For example, the diameter is 1 to 1000. They are heterogeneous, don't forget that, and they don't settle out. So since they don't settle out, and sometimes the particles are very small, we might get mistaken for solution. Sometimes you might think a colloid is a solution. You might think a colloid is a solution. Then there must be something in order to distinguish between colloids and solutions. يعني باش تشك من هبه كولويد منين رنجا لنجا لسولوشن بتشي اي شلون جام كينو اگر هاد لسولوشن يكشو بتابتي لموضوع الليكويد كان ياخذ موضوع الغاز كان بتابتي. There is another thing. Many colloids appear homogeneous, see, because the individual particles cannot be seen. The particles are however large enough to scatter light. What does the scatter light mean? Now we come to scattering light. Look at this figure. Look at this figure. This is a solution. This is a solution. This is a colloid. We cannot see the light passing through the solution, only very little. We assume that the light is not seen throughout this solution. But if you look at the same light, and it's also transparent, you can see the light has passed through. But if you look at the colloid, we can see the light passing through this mixture. This light that is seen here is actually scattering light. This is called scattering light. Let me give you another example. If you are sitting in your room right now and there is a light bulb working, look at the light bulb and the distance between the space between the light bulb and you. Can you see the light in the air? Of course not. حاجة سيري بيني أو لا يتقلبك تنداقي السانبة تنانات خورش سيري هواكبك بزان الهواكا وك أو رسمته رناكي كابينيت ناخر نابيني سيركي هيجو رناكيك ديارنية رناكي كرق حتى كشتكنية تبردم رناكي كدرناكه. So you cannot see the light until it hits something, until it's reflected from something. So that space between the light and you is a solution. We said air is a solution. And if you go back to the properties, air, like here, or solutions, which we are talking about, for example, air, they don't scatter light. So you cannot see light through air. In order to clarify more, imagine, most of you have seen foggy nights when you go out and you look at the headlights of a car. You can see the light passing through the fog or the fog particles, which are colloids. That's what is called scattering light. But during any other night, for example, these nights in this summer, our nights are very clear. There is no colloid. Go out one night. For example, tonight you can test it by yourself. Go out and look at the headlights of a car. You can see the headlight. You can see it hitting to the pavement. But you cannot see the light passing through the headlight through the air. Unless there is some dust. There is some like very small particles. Sometimes when there is dust, you can see the light. Or for example, you may have seen in your homes when your mom draws the curtains or removes the curtains and they vacuum clean your house, you can see dust particles playing around in front of the sunlight. The sunlight, normally you cannot see the sunlight passing through into your room. You only see the sunlight that is hitting the wall or that is hitting something. But in between, you cannot see the light unless there is dust. The dust is a colloid. The fog is a colloid. All right? So colloid particles, why do they scatter light? because they have a close or bigger size particles than what? Than visible light wavelength. Laboratory particle can, so since the particles are bigger, they can intercept the light rays that is coming through, and they can go in front of the light and scatter the light. كاتە لێرە فکرەکە چییە؟ ئەگە بە کوردی بۆتان شەرحکەم. کۆڵۆید لەبەری پارتیکڵەکانی تا حەدێک گەورەیە ئەتوانێت بچێتە بەردەم ڕووناکیەکە و وەکو بڵێ ڕووناکیەکە بڵاو کاتەوە چای تۆش ببینێ. بەڵام پارتیکڵی سۆلوشن ئەوەنە بچووکە ناتوانێت ئەو ڕووناکیە ئەو ڕێیەکە بە بەردەمی ئەڕوات بتوانێت بڵاوی بکاتەوە تۆ چاوی تۆ ببینێت. وەکو ئەمەی کە مەسەلەن لەبەر چاوتانە لە ڕسمەکەیە. مثلا بڕۆ سەیری لە یوتیوبە چەندە سەی ڤیدیۆی کۆڵۆید و سۆلوشن بکەیان بنووسە تیندەڵ ئەفێکت یەکسەر هەموو ئەمانە پیشانەیە. باشە باسی زیان بنووسە سکاتەرنگ لای. Alright. So what do we call this effect? What do we call this thing? This property? We call it Tyndall effect. This scattering light by colloid particles is called Tyndall effect. Alright? So Tyndall effect is the scattering light by colloids. So Tyndall effect is a property that is distinguished or that is special only for colloids. Only colloids have Tyndall effect. Only colloids have Tyndall effect. Not suspensions, not solutions. So if it says, what is Tyndall effect used for? Tyndall effect is used for distinguishing between solution and a colloid. I think I have seen this question. Tyndall effect is used to distinguish of one of them. I have seen this question like 3 times. I have written 2 times here. I think I've seen it another time as well. So Tyndall effect is used to distinguish for which one of the followings. Of course, you have to look at here solution and colloid. So the answer is B. All right, the answer is B. Any questions, please? بعضور هنا كين لسر زخت أنا سرنا كمان تبغى نرجع برا مسار موضوع كي تبتر زور باش يعني من فرق بابا بسر شاو باشا Tyndall effect على شيء بريتيا لا سكاترينج شيء بكردي وما بيتر پردبون واتا بلاو کردنەوەی ڕووناکی کاتە بریتە لە بڵاوکردنەوەی ڕووناکی لە پەردبوونی ڕووناکی بەهۆی چێوە بەهۆی پارتیکڵەکانی کۆڵۆیدەوە کە چیان لێ هاتوو پارتیکڵەکان کە دیسپرس بووە لە ناو میدیەمێکی ترانسپارنتە بۆ نمونە پارتیکڵی سمۆک دیسپرس بووە لە ناو هەوایە هەوا ترانسپارنت نییە با کەواتە کە پارتیکڵی سۆلید وەکو ئەوی سمۆک بڵاو بێتەوە بە ناو هەوایە ئێمە ڕووناکیەکە ئەبینین بۆ نمونە ئێستا لەیزەر طبعا ڕەنگە کەستان دقەتی ئەمەتان نایابێ بڕۆ لە شەوێک کە هەواوی پاکەواکەی تۆزە پاک بێ لەیزەرە بە لە دیوارێک دەمی لەیزەرەکە بینی لەگەڵ لەیزەرەکە لەسەر دیوارەکە بینی لەیزەر و دیوارەکە کە هەواکەیە نایبینی لەیزەرەکە بۆ لەبەرەوەی ئیلا ئەبێ کۆڵۆید بێ بتوانێت ڕووناکە دەرکات بەڵام لەو کاتێک کە تۆ لەیزەرەکە بەکارهێنیت بڕۆ تاپوتۆزێک دروستکە سیرێکی وردە و دەخەتی لەیزەرەکە دەرەکەوێت بەم حاڵەتە کە خەتی لەیزەرەکە دەرئەکەوێت بەهۆی چیەوە بەهۆی ئەوەی کە پارتیکڵی کۆڵۆیدەکە کە بەهۆی تەپوتۆزەکەوە چۆتە بەردەم ڕووناکی لەیزەرەکە ڕووناکی لەیزەرەکەی بڵاو کردوێتەوە سکاتەری کردووە بەمە ئەوترێت Tyndall effect باشە for example most of you have seen movies in some movies where for example they want to protect something. I have seen a lot of movies like this. When they want to protect something, they guard it with laser beams. You can see there are a lot of lasers that going through that place or that hole. What do they do in order to see the lasers? Look at some movies. If it's a correct movie, they don't do fsha things. أجا fsha fshushti تيانا به. In the movie, they put smoke into those lasers. Why? Because the smoke is colloid, it will show the laser light because it will scatter the light. That's why they use smoke. لازم فیلمەکان ڕێک وایە بە لێزەر کە شتێکیان ئەپارێزن بۆی کە کەسێک ڕۆی یەکسەر ئاگادار بن چیەکەن ئەچن دووکەڵێک هەڵێنە ناو لێزەرەکەەوە بۆی بڵاو ببێتەوە لێزەرەکان دەرکەوێت ئەگینا خۆی لێزەرەکە دیار نییە ئەگەرم جاریان شتێکی واتان بینین دیقەتی بن لێزەرەکە دیار نییە ئەو حاڵەتە پێی ئەوترێ تیندەڵ ئەفێکت ئەم ڕۆژهەر خۆتان توان لە ماڵەوە تاقی بکەنەوە. You can test this at home. You can test Tyndall effect. It's very, very easy. You can even do it with your cell phone's light. You don't need even a laser. Bring two glasses, but very clear glasses. Do padahi aruni awi bena ka hiç tanana nakhshi shitiyana be boy la jwani darka nakhshi shitiyana be. Bring two glasses which they don't have anything. They are very, very clear. In one of them, put clear water. In the second one, put some water and a lot of tea. Just tea, normal tea. But it's better to be a light tea so that you can see the light more easily. Put your cell phone light right next to the glass. You cannot see the light through the water. You can see the light passing through and it hits the other side of the glass and it just passes through without seeing the light inside the water. But if you pass through the same light through the tea, you can see the light going through. You can see the whole path, the passage of light going through that tea. ئەگەر تێگەش بن چیەکەن پەرداخێکی زۆر ڕوون بێنن دوو پەرداخ یەکێکیان بە ئاوی سافی تیابێ یەکێکیان نەختی چای لەگەڵ ئاوەکە تێکەڵ بکەن بۆی تەڵق بێت تا چاکەی تۆزێ با بڵێن نیوانی تێکەڵ بکەن لەگەڵ ئاوەکە یاخود بەشێکی تۆزە زۆری چابێ بەشێکی ئاو بێ با تۆزە ڕوون بێ بەس لایتەکە بن لە پەرداخەکە بەت پەرداخەکە بنووسن لایتی مۆبایلەکەتان اینجا سێریکەن سێریکەن ڕووناکیەکە بەناو ئاوەکە یەکسەر ڕۆشتە بەبێ لە ئاوەکە دیار بێ بەڵام سێری چاکە بکەن لە چاکەیە ڕێک خەتی ڕووناکیەکە دەرکەوتووە ئەو حاڵەتە پێی ئەوترێ تیندەڵ ئەفێکت کەواتە بۆ لیا بۆ دەرەکەوێت کە چاکەی ماوە مەزانی و سۆڵوشنە بەڵام ڕاستیە پارتیکڵی چاکە وای لێ کردو ئەو میکسچەرە ببێ بە کۆڵایت باشە sorry about that. There you go. Now, under a microscope with a bright light, the particles which appear as tiny specks of light are seen to move rapidly in random motion. Yani, this is for colloid, of course. All right, this is for colloid. So if we put a colloid under the microscope with a bright light, we can see the colloid particles which appear as tiny specks. Specks means like very small, tiny things, are seen to move rapidly in a random motion. For example, if you look at smoke, not even a microscope, even without a microscope, if you look at smoke in a very bright area, you can see the smoke particles are always moving. They don't stop. They don't stop throughout the air. Even inside the liquid, the particles don't stop. This motion, this continuous motion, this rapidly random motion, is due to collision. So they are random. Some particles go to the one side, the other particles go to the other side. They are due to the collision of rapidly moving molecules. So the molecules are actually hitting each other. Collision means hitting each other. And we call this motion as Brownian motion. Why is it called Brownian motion? After its discoverer called Robert Brown. So that the motion that you see in smoke or fog, even in fog, you have seen it during the winter. The fog particles don't stop. They always move. They always move. Especially in the morning when you wake up and you can see fog particles, they are always moving. This movement, and they are random. They don't go to one direction. It's called Brownian motion. All right. So if it says what is Brownian motion, is the continuous particles or the random motion of particles which is seen in colloids. لأنها colloid أبنية. We have one last question. Which of the following is not separation method between solution and suspension? So this is a very good question. كم لمعنى بو جاكرني solution suspension بكارنات. يا كمان تندل افكت واحد تندل افكت بو شي بكاريه بس تندل افكت بو این بکاریت بس با سولوشنو كولويد بكاريت باشا بابين سر اويت يعني filtration بالفعل filtration اگر دقت نابه if you look at filtration solutions don't get filtrated but suspension can be filtrated. Suspension can be filtrated. Standing means precipitation if left to precipitate. Yes, solutions don't precipitate, suspensions precipitate. So these two are used as a separation method for solution and suspension. Solution and suspension. This is important. This is like a note for you. You can look at it as a note. So it's also not D because yes, C is used for distinguishing between separation between solution and suspension. Filtration is also used. That's why the only answer is actually Tyndall effect. Any questions? هل بسيارك أنا هبه بسيارك تام كم بعدين. اگر بمعنی solution suspension لیک جاب کینوا اگر بگرتو solution با precipitation جانبته وانیا يعني اگر نه precipitate كأنه filter وانیا بلام suspension هم precipitate كات هم filter شكلت كواتا اتوانين solution suspension بود جاب كینوا اگر شتك filter كرا على نو suspension filter نكرا على solution ياخذ precipitate هبو على suspension precipitate نبو بونونا على أو solution أقل لبين أو دوانة أبو على بواجي أنا كينو. Okay, very good. Let's continue. Now this table here, you can see it contains all the properties. Even if we have missed anything, and I don't think we have, everything is written here. It's a table that separates solutions, colloids, and all the properties of all of them, and suspensions. Now, if you don't have any questions, let's continue to the next subject. From now on, we close the doors on suspensions and colloid. We don't talk about those anymore. We will only talk about solutions. Until the end of these chapters 2, 3, 4, all the things that we talk about are actually solutions. Now, there are two types of solutes which they make solutions. They are either electrolytes or non-electrolytes. What does electrolytes or non-electrolyte mean? Electrolytes, a substance that dissolves in water to give a solution that conducts electric current. So this is the definition. If a solution or if a substance, when dissolved in water, it can give it can conduct electric current, we call that solute as electrolyte. And electric conductivity, we have to bear in mind, it depends on the presence of ions. So if a solute dissolves in water and they become ions, then that substance, that compound is an electrolyte. كواتا هشتك لأوة وايوة كهرباء جانا وإلكترولايت أو جان بناش بش بتشي بستيت بش ببوني آيون بستيت أبي آيوني تادرس ببيت. First, let's explain something. Does pure water conduct electricity well؟ اگر یەکتان جوابم بەنەوە بۆن منە ئایا ئاوی سافی کارەبا باشێگەێنێت؟ No. ناگەێنێت زۆر تەواوە. So pure water does not conduct electricity well. So we have to put something else in order for that water to conduct electricity. What are those compounds which can conduct electricity? For naming the compounds or for recognizing the compounds, we will learn about the compounds in the next chapters, especially in chapter 2 and 3. But for now, we have to know the basic knowledge, which compounds become electrolyte? All soluble ionic compounds. So for ionic compounds, you know what are the ionic compounds. If we have a cation and we have an anion, from the two tables that I told you yesterday, and they dissolve in water, such as those ionic compounds are either salts or strong bases, they are electrolytes. For example, NaCl. Look at here, it's NaCl. NaCl is a salt. When dissolved in water, see, it becomes, or it separates into its original ions. كواتا أو أيوناني كإملا بوليانزا تيولا كان أخوان مان ككاتك أبن بو compound أجر بيان خينونا أو دوبار أبنو بأيون أصلك. So if the ions that we studied last year, that you have studied in 11th grade, if we they become compounds and they are solid. But after we put them inside the water, when they dissolve in water, they separate back to the ions again. So this compound is actually an electrolyte. Why? Because, as I said, electric conductivity depends on what? Presence of ions. So if ions are present, then that solute will conduct electricity. And since NaCl can supply ions into the solution, then it will conduct electricity. Look at this solution here. This is a solution of NaCl. You can see the light bulb is working. It means that this solution here is conducting electricity. Same thing for polar covalent compounds, especially high polars. Like what? Like all acids and weak bases. As I said, we will study all the acids and weak bases in chapter 3. So don't worry about that, because when you study for chemistry, as I said, they are all connected together. When you enter the ministry exam question, the question asked going to be related to like 2 or 3 chapters. You have to connect them together. Now, for here, all the acids and weak bases, we're going to also talk about them again in chapter 3, that they conduct electricity. They also are electrolytes, such as here. You can see this is hydrochloric acid, HCl. Hydrochloric acid is HCl. HCl, when dissolved in water, it forms ions, Cl ions. See? These ions conduct electricity, make the solution to conduct electricity. Same thing. How these are working? Positive and negative ions separate from each other in solution are free to move, making it possible for an electric current to pass through the solution. So since they are freely moving, they can, when they hit each other, when they collide each other, and they are charged, these charges can transfer electric current from one side of the solution to the other side of the solution. And anything making a solution to conduct electricity, we call them electrolytes. All right. What about non-electrolytes? Non-electrolytes, a substance that dissolves in water to give a solution that does not conduct electric current, is called a non-electrolyte. See, they dissolve. We don't have a problem with dissolving. They become solutions. But when they become solution, they just don't become ions, they just don't conduct electricity. That's it. But they actually dissolve. Like what? Like in the intermediate polars that we talked about in the first page, or low polars. Such as what? Such as sugar and alcohol. Then if they dissolve, so for the ionic compounds, if you pay attention to this side, when they dissolve, they become ions. What about these ones? When they dissolve, of course, these are all molecules, but this is solid molecule. When they dissolve in water, what happens to them? They stay as molecules. اما بمعنى molecule. ككاتك compound یک معنى بيت covalent compound بيت ببچوكترين يكي covalent compound علين molecule leg molecule بيكاتوا. So the smallest unit of covalent compound or molecular compound is a molecule, and they dissolve as molecules. If you see this part, only the physical state has changed from solid to aqueous. So last year, also in 11th grade, we had a table. You don't have to memorize that table. I'm just reminding you. If it says AQ, it means dissolved in water. AQ means aqueous solution. كواتا قلوتي AQ يعني أمشتب تواوتوا لا تشيشا تواوتوا لنا آوتوا واتلا physical state أصلكي خوينا معه. So we call this molecule as dissolved molecule. كات حركاته تو AQ بيني يعني لآوتوا أجر آيون نبو أساس هيركا. If you look at here, which we are going to clarify it in section 2 about ions in water. But just for now, if an ion is also dissolved in water, can be aqueous as well. We will say a dissolved ion. But this one is only a dissolved molecule. Let me give you another example. So this is sucrose. This sugar is sucrose. Same thing for glucose or ethanol or alcohol. So glucose is C6H12O6 and it's solid. If dissolves in H2O, see it dissolves in H2O. It just doesn't become ion. It cannot get separated to ions. It becomes C6H12O6. But instead of solid, I will write AQ. That's the only difference. So when you dissolve sugar in water, the sugar particles, the sugar molecules are dissolved in the water, they are disappeared in the water molecules surround the sugar, and you cannot see the solid anymore, but they don't become ions. So if you look at this figure, you can see sugar molecules are dissolved in this part, in this solution, but since sugar particles do not form ions, that's why they become a non-electrolyte. They are counted as a non-electrolyte. All right. So these are the differences between electrolytes and non-electrolytes. كات أما جوازك أجر هاتو ميمتنيش من لجاندني كهربايا أويكا آيوني تيابت كهرباء جانت بلام أجشتيكي وكو الشكر كآيون دروز ناكات أو كهرباء ناجانت كواتما بعام أو كماولن كإنترميديت بولارا كاني كهرباء ناجانن حتى كو أخيري هرت موضوع الهر شوي أتغير أم موضوع الكيمياء كإخوانين أو كهما بتوتو الأوو كهرباء ناجانية أو سجورشتن شكر بدوينكه وبدو نمونكه وسكروز وغلوكوز لقد الكحول كان إذا جيشنا شابتر 11 بونمنا لكاتي مكتبه لشابتر 11 مثلا تو هم الكحول كان خوني أزاني الكحول شونه و بۆچیش دووبارە ئایۆن دروست ناکە بەڵام من لێسا لێرە بەزەوە نەزانین ئەڵکۆهۆڵ یەکێک نییە لەوانەی ئایۆن دروستکە ئەگەر تۆ بینیت لە سەکشنی دووشە من سترەکچەری ئەڵکۆهۆڵ ئەثانۆڵتان بە تەرتیب پێڵم چکە لویا بە وردی باسیەکەین کە تۆ ئەثانۆڵ بینی وتی تواوەتۆ لەناو ئاوە بە سترەکچەرەکەی ئێماڵێن کارەبا ناگەێنێت ئەتوێتەوە لە ئاوە بەڵام کارەبا ناگەێنێت بۆ because they don't contain mobile charge particles mobile charge particles یعنی چی؟ ions بلویایە mobile charge particle مەبەستی لە ئایۆنە
ئایۆن دروستەکە بەس ئەو نمونەیە دروستی ناکات
ئێمە وردەودا خۆی وردەودە شتەکانمان بۆ جیابێتەوە ئەوەی کە ئەتوێتەوە لەناو ئاوە بەوە جیانەکەنەوە هەنێک ئەشتت لە ئاوا توێتەوە هەنێشت ناتوێتەوە ئەوەی کە ئەتوێتەوە لەناو ئاوە ئەکرێ بە دوو بەشەوە کارەبا ئەگەێنێ یان ناگەێنێ ئەوەی کە ئەتوێتەوە عادەتەن ئەوانەی کە ناگەێنێت ئینتەرمیدیەتەکانن کە چییە شوگەر و ئەڵکۆهۆڵە باشە ئاوەهی کەسی دەستیار نییە زۆر باشە I have added the section review answers as well but we will try to solve them together so that I can yes do you have a question بابا again فرم
لا يتذكر موضوع الالكتريك كومباوند يتذكر الامر الى اكيد الذكاء عندنا الذكاء تذكر ترتيبا
كمان بابا again
والله هتاكو الكتريك كومباوند كمية
لا الكترولايت كوت يعني قشتي
عليه بخار تنقشم هتاكو يا تقشم عليه بخار تبدلا نارنا يعني زين تنقشم
باشا يعني انس يلا كتقشتي
كمان اولي بلا
انس يلا كتقشتي كبوتش كهرباء جانا
امي الكترولايت تنقشم يعني الفار تنقشم كومباوند تنقشم بس اول تلسر
باشا اسمن تتجانم كشنا بليرا دوباره كينو بابگەن خۆی ئێمە کۆمپاوندەکان بەپی گیانی کارەبا لەناو ئاوە ئێمە بەس باسی ئەو شتانەکەین کە لە ئاوا توێنە باش نییە دوو جۆرن یانەوە کارەبا ئەگەێنێت کە کردمان لەناو ئاوەکۆ شتێکی واگە کە کارەبا بگەێن یانەوە کارەبا ناگەێنێت گەاندنی کارەباکەش پەیوەندی بە چیەوە هەیە ئایا ئایۆن دروستەکات یا خودنا هەموو ئەم کۆمپاوندانی سەرەوە ئەم مەجموعانی سەرەوە بۆ نمونە ئاینی کۆمپاوندەکان ئاینی کۆمپاوندەکان کامانەیە ئەوەی کە پار لە تێڤڵەکەیە خوێنوتە کە کاتێک کەتایانێک و ئەنایەنێک پۆزیتیڤێک و نەگەتیڤێک کە یەکیانەگەر ئاینی کۆمپاوندیان دروستە کرد ئێستا و ئاینی کۆمپاوندە کە لە ئاوا ئەتوێتەوە دووبارە جیا ئەبێتەوە بە ئایۆن ئێتە مەسەن ئاینی کۆمپاوندەکانێمە لە دواترا سۆڵتەکانە خوێنین سۆڵتەکان هەرچیەک لەوەی تێبڵایەتیەتی زۆربەی سۆڵتە یعنی لەو تێبڵە دوو تێبڵەیە کەتان و ئەنایەنێک پێ و بنووسێنە زۆربەی سۆڵ دەرەچێت بەس تەنها یەک نمونەمان هەیە گەر مێتاڵێک و OH بوو یەکێ لە ئەنایەنەکان OH بوو ئەو سترۆنگ بەیزە مێتاڵێک لەگەڵ OH-ێکەوە سترۆنگ بەیز ئەمانە لە ئاوا ئەتوێنەوە کە ئەشتوێنەوە جیا بێتەوە بە ئایۆن لەبەر خاطر و ئایۆنانە کارەبا ئەگەێنێت یعنی هۆکاری گیانی کارەباکەی بەهۆی ئایۆنەکانەوە بەڵام polar covalent compounds مەسەن ئەسیدەکانیشمان هەیە مەسەن پاری ئەو ئەسیدتان خوێنووە ئەسیدەکان مەسەن چی تایە پۆلی ئەتۆمیک ئایۆنی تایە کاتێک کە جیا بێتەوە ئەبێ بە پۆلی ئەتۆمیک ئایۆنەکان یاخود مەسەلەن هەر ئایۆنێکی تری تایە ئەنایەنێکی تری تایە بۆ نمونەوەکو HCl ئەبێ بە چی و چی ئەبێ بە HCl ئەمە کە جیا بێتەوە ئەبێتە هۆکاروی کە کارەبا بگەێنێت ئەمە ئەلکترۆلایت ئەینەن ئەلکترۆلایت چییە کاتێک بتوێتەوە لەناو کۆمپاوندەکە عادەتەن کام کۆمپاوندانن یعنی هەر کۆمپاوندە مانەر باسیەکەمی کۆمپاوندن باسی کۆمپاوندێکەکەم کە تا حدێک پۆلاریتەکەی نزم بێت لۆ پۆلار بێ یاخۆ ئینتەرمیدیت پۆلار بێ ئەگە بگۆڕێتەوە سەر لاپەڕی یەکەم ئینتەرمیدیت پۆلار بزانە چی نووسراوە ئۆتومانە عادەتەن کاربۆن و هایدرۆجین و ئۆکسجینە سێری ئەمە بکە ئەها لەگەڵ ئەمە سەکرۆزەکە لەگە گلوکۆسەکە هەردووکیان چییە؟ هەردووکیان کاربۆن و هایدرۆجین و ئۆکسجینە کە توانومانە تۆ لە ئاوا هاتووەتەوە کێشەی نییە بەڵام بە سۆلیدی بەڵام بە سۆلیدی گۆڕاوە بە ئاکوسی واتە لە حاڵەتی سۆلیدەوە بۆ منەوە شەکرێکە بەدەستی تۆیە سۆلیدە کە لە بەرچاوی تۆە سۆلیدە بەڵام کە ئەیتێنە ناو ئاوە ئەوە بە ئاکوس بۆ لەبەری تواوەتەوە لە ئاوەکەیە لەو حاڵەتەیە تواوەتەوە بەڵام لەبەرەوەی ئایۆنی دروست نەکردووە بەخۆی ئەڵێن چی بەو شەکرە پێی ئەڵێن مۆلیکیۆڵ چونکە شەکر چییە یعنی پۆلارەکان ئەگەر دوستە تێبڵ یەکەم پۆلارەکان سەر بە چ جۆرە کۆمپاوندەکان کۆڤالەنت کۆمپاوندن کۆڤالەنت کۆمپاوندەکان چی تریشیان پێوترێ مۆلیکولار واتە بچووکترین یونیتیان چییە مۆلیکولە بچووکترین یونیتیان مۆلیکولە ئەم مۆلیکولە کە ئەتوێتەوە لەناو ئاوە هەر بە مۆلیکولی ئەمێنێتەوە ئێستا مەسەلەن ئەسیدەکانش خۆ هەر مۆلیکولن ئەوەی کە لەسەرەیە بەڵام ئەوانە بن بە ئاین بەڵام ئەم مۆلیکولانە سێ نمونەیە بیزانە گلوکۆز سەکرۆسەر و سێ نمونێشمانە لەگە ئەڵکۆهۆڵ کە توانەوە لە ئاوە خۆی چ مۆلیکولێک هەر بۆ مۆلیکوڵ ئەمێنێتەوە نەجیابێتەوە نەئەبێ بە ئاین نە هیچ لێت لەو حاڵەتەیە ئێمە ئاڵێن ئەم مادەیە مادام گیانە بۆتەوە مادام ئایۆنی دروست نەکردووە کەواتە ئەمە نەن ئەلکترۆلایتە باشە بابا هیوادارم جوابی پرسیارەکەم مابێتەوە تێگەشتی بێتی سەرخۆش بێ هەر کاتێکی تریش تێ نەگەشتی لە کاتێکی خارجی دەرسەکە پێم بڵێرەوە بەسەر چاو زیاترش بۆ دڵ نەکەنەوە Alright, now let's come to the section review. Sometimes section review is very important, especially with some questions. So for example, here in section question 3 is not important because it says make a drawing and you don't need drawing actually. So you can just cancel question 3. All right. But let's go to number 1 and let's explain number 1. Classify the following as either heterogeneous or homogeneous mixture. Explain your answers. So, what is an orange juice? Orange juice is heterogeneous. Orange juice is heterogeneous. It's not homogeneous. Why? Because there are still big particles which don't dissolve, and actually if you leave orange juice you can see it precipitates. For example, leave it overnight. In the morning when you look at the orange juice you can see big particles precipitated in the bottom. That's why they become a suspension. And if you look at the answer key, it says heterogeneous. Orange juice is heterogeneous. Why? Because the pulp and aqueous components together constitute a suspension. And some part of it has dissolved, but some parts have produced a heterogeneous, some part has produced a suspension particle. That's why they are heterogeneous. What about tap water? Tap water is homogeneous. Tap water contains a lot of minerals, and actually tap water contains a lot of ions. ئاوی بەلوعە ئایۆنیتیایە بۆیە ئاوی بەلوعە کارەبا ئەگەێنێت جا زۆرجار تەلەبەکە پێڵی ئاو کارەبا ئەگەێنێت ئاوی صافی پیۆرشتەوە ئەڵێ بەڵێ بۆ بیر لە ئاوی بەلوعە ئاکاتەوە بەڵێ ئاوی بەلوعە لەبەروی ئایۆنیتیایە کارەبا ئەگەێنێت. So tap water is actually homogeneous, which contains solutes and actually contains ions. That's why tap water conducts electricity. It's an contains electrolytic solutes. Electrolytic solutes. Next question. Question 2. What are substances called whose water solutions conduct electricity? We know that. It's solutes. Electrolytes. Electrolyte solutes. B. Why does a salt solution conduct electricity? As I said, because they form or they produce ions inside the solution. وجدتي بوشي salt. كهرباء كاتلنا وآوابو. Solution نجيبو كهرباء لبري ion درسكات. لبري كأتوتو أبيب ion. C. Why does a sugar water solution not conduct electricity? أي شكر بونجينه لبري رك بعكس يساره. Because sugar is low polar and cannot form ions. They remain as dissolved molecules. لبري چی تیانیه؟ charge particle تیانیه، mobile charge تیانیه، ion تیانیه. شکر که اتویتو لنا وەکووتمان ئەتوێتەوە بەڵام ئایۆن دروست ناکە لەبەر ئەوە طبعا لێرە ئانسەرکێکە شتیا لە خوارەوە بەڵام من حەزەکەم بۆتان شەرحکەم و بۆتان ڕوونکەمەوە.
So,
Yeah,
may I ask a question?
yeah, sure.
For question 2B,
B, yes.
can we say a salt solution conducts electricity because it produces ions when dissolved?
Of course, yeah, that's the answer actually. Yes, as you can see, because if you look at the answer down below, a salt solution conducts electricity because mobile ions can move a charge from one point in the solution. So because they form ions, that's exactly the answer. Correct.
Okay, thank you.
You're welcome. Describe one way to prove that a mixture of sugar and water is a solution and that a mixture of sand and water is not a solution. مثلا ربط شي أزاني ك پرسیارێکم هێنا بۆ لەولا پرسیارێکی هەڵبژاردن. Actually this answer is like this question here. Question 4 is like this question, the one that's above the table. This one here. This is like question 4. It says describe one way. Why? Because sugar and water is a solution. Sand and water is not a solution. It's a suspension. How can we distinguish sugar and water if they get mixed, if they become a solution? Do they form a precipitate? No. Do they get filtered? No. Because instead of one way, even the answer says two ways actually. Look at the answer. There are two ways. Sand and water settle or can be filtered out, proving that it's not a solution, it's a suspension. While dissolved sugar cannot be removed from water through settling or filtration. There are two ways. Filtration, so you can prove it by these two ways. Filtration and precipitation. Filtration and precipitation. يعني اگر جوابێکی کورتمان بنووسین ئەوە جوابەکە ئەبێت. Filtration لەگەڵ precipitation. Like this. You can use those two. Question 5. Name the solute and solvent in the following. 14 karat of gold. Of course. The solvent is gold. The solute is silver. As I said, we will answer it according to the Kurdish one. Even though in the answer key says solvent is gold, the solute is silver and copper. But I imagine, or I presume in the ministry exam question, they will delete the copper for you. You will only have silver. Corn syrup.
سۆڵەتەکە سفرەوە
سۆلوتەکە سڵڤەر بەڵێ
سۆڵەتەکە گۆڵدە
هەرچۆنێک بێت ئایارە چواردە ئەگە بڕێتۆ سەر فیگەرەکەی کە باسمان کرد لە 58 گۆڵدا کەواتە زۆربەی زۆری گۆڵدە
بەڵام لە 12 بۆ بزانم دیار نییە کامیان سۆڵەت
باشەتە لە 12 بەس تەنها سیلڤەر و گۆڵد بێ لە حاڵەتیان نازانی یعنی نابێت کەپەریتیا بێ باشە چکە ئەگە کەپەریتیا بوو بەڵێ
یەکەم جار ئەبێ سۆڵڤنتەکە بسترێن سۆڵوتەکە
بەپێی خۆتە بەس لێرە هیچ کێش ئاهات لەبەری لە بەباهینەکە دەستکاری کردووە با بڵێن لە تێبڵەکان لەسەر نووسێتی سۆڵڤنت و سۆڵوت کێشەمان نابێت بەڵام ئەگەر هاتوو بە شەرح بیکەیت ئاوا باشترە ئەگە بە شەرح بیکەیت ئەڵێی سیلڤەر ئین گۆڵد ئەگە بە شەرح بیکەیت بەڵام ئەگەر بۆ نمونە بە ئاوا بیکەیت ئەڵێ the gold is solvent the silver is solute یعنی بێ ڕوونی بکەیتەوە بەڵام قسەکەی تۆ تەواوە ئەگە بە شەرح کرد ئەبێ یەکەم جار سیلڤەرەکە بڵێ باشە سەر خۆش بێ corn syrup the solvent is water corn syrup هەر شیلێ ئەو شیلکەکرێ بە سەر خواردن وشتە so corn syrup is the solvent is water the solute is sugar that's corn syrup. Carbonated or sparkling water. Carbonated or sparkling water means carbonated beverage. since it says carbonated, so it's gas in water. So the solvent is water, the solute is gas. But what is the gas? The gas is CO2, just like the one it said in the table. So CO2 in water. CO2 in water. As you can see,
أمامه كربونيتد
بله چونکە کەوتی carbonated یا sparkling water مەبەستی لەوەیە کە غازی تیا غازەکەش چییە؟ CO2. هەر کاتێک گوتی soft beverage
ما بنووسی هەر لە خوار ما بنووسی بۆ ئێمەش لە خوار لە لای خۆمان بنووسین ئازاد نەبێت
چۆن یانی لە خوارەوەتان بنووسم لەلای ئەمە ئەسەر
لە خوار لەم سپیاتی ئازاد ما بنووسی بڵێ کاربۆنێت سۆلیدەکەی سۆڵبندەکەی ئەوە بۆی بزانین
باشە بەسەر چاو ئەوە تا لێنەکە تیاتی مەزەمەکە دەگەر لا بە هەر لێرە تیاتی
لا مامەسە
لەویا تیاتی بووە من زۆرینی ناکەمە گینا لە سپێکا بۆتان نووسم. Question 6. We have a couple of minutes. We'll wrap up question 6 and we are done for today. If you allow a container of seawater to sit in the sun, the liquid level gets lower and lower and finally crystals appear. What is happening? So seawater contains what? Chiti seawater.
Salt.
Yes,
Salt,
it
yeah.
contains salt. Suppose seawater is salty. So if we leave the seawater, the H2O evaporates. The H2O evaporates. Only the salt is left behind. That's why we can see crystals appear. The same thing, water is the solvent, is evaporating. Look at the answer key. Leaving behind the dissolved salt as solids. So that is also the answer of these ones. Any questions? Happy Seriktan again? If not, we are done for today. Have a nice day, everyone. You have other classes. Good luck with the other classes as well. Very well. خواتان لقد جماعة.
الله
Just